Okay, so let's say we're doing an inequality that's not an absolute value, but it's something way more complicated than just a line. So this would be a polynomial inequality. Now the nice thing about this is once you learn this method, it's going to work for lots and lots of different types of problems. No matter how complicated the problem is, we're going to work it the same way. So what you first do is find the critical points, the places where this thing equals 0. So that would be at x equals -3, x equals -2, and x equals +2. If I plug any of those numbers in, I get zeros in one of the parentheses. So those are my critical points. Then I make a number line. So I'm going to put a number line over here. So, and I'm going to put them in order. These happen to be in order, but they're not always that way. So you want to make sure you put them on the number line in order. So you have a -3, a -2, and a +2. So we're going to have 1, 2, 3, 4 sections of numbers to check. Okay, like all the numbers in the world are either smaller than all of them, having flashbacks from when we did this before. It's going to be in between -2 and -3, in between -2 and +2, or bigger than 2. Every number in the world falls into one of those 4 categories. So we're going to test every one of those categories. Okay, so let's pick something smaller than -3. So I'm going to pick -4. Doesn't matter what I pick because the zeros only happen at these places. So -4 is going to act the same as -10 as -20 or -3.782. Like it doesn't matter. So just pick a simple number smaller than -3. We're going to have to do decimals in here. So -2.5. I'm going to pick 0 here and then 3 here. Now, notice the numbers that come from my problem that are critical points, I put on the bottom of my number line. The numbers that I randomly picked, I put on the top and I circle them. It doesn't matter how you distinguish between them, but I recommend distinguishing between them somehow. If you use -4, you're not going to put -4 in your answer. Your answer is going to contain the critical points. So keep them straight so you don't accidentally put the wrong number down. Okay? So we're going to take -4. And we're going to plug it in here, and all we care about, because we have it set equal to 0, is whether or not it's positive or negative. Because positive numbers are bigger than 0, negative numbers are less than 0. If this was greater than or equal to 7, it would be a lot harder. But just because it's greater than 0 means I can just look and whether see if it's going to be positive or negative. So if I plug -4 in here plus 3, I'm going to get a -1. I don't even care that it's a -1. I just care that it's a negative number. If I take -4 plus 2, I'm also going to get a negative, and -4 minus 2 is another negative. When I multiply 3 negatives together, do I get a negative or a positive? I get a negative. So every number in this section is going to give me a negative answer because it's going to be a negative times a negative times a negative. Now if I do -2.5, -2.5 plus 3 is positive. I don't care what decimal it is, but it's going to be a positive number. -2.5 plus 2 is going to be a negative. -2.5 minus 2 is another negative. What's a positive times a negative times a negative? Positive. Now, normally these will alternate, okay? And if you get good at knowing what the graph of something looks like, you'll know whether they alternate or not. But for most of you, I suggest you plug the numbers in and check. You also can put this in your graphing calculator and look and see, like if you get confused on the numbers for some reason, you can plug them in and see if you get a positive or negative, but you shouldn't have a lot of trouble with this part, doing the arithmetic, okay? So if I plug in 0, 0 plus 3 is positive, 0 plus 2 is positive, 0 minus 2 is negative. One negative makes a negative, so that's negative. If I plug 3 in, I get a positive times a positive times a positive. 3 positives makes a positive. Okay, so now we have our results. Now we need to write our answer. Are we looking for positives or negatives?
Negatives.
Really?
Positive.
Positives. Greater than or equal to 0 would be positive numbers, right? So I'm looking for things that are greater than 0. I'm looking for positives. So that means this is my answer and this is my answer. So then if you use interval notation, it's pretty easy to write it. Am I going to be using brackets or parentheses? Brackets, because I have a line there. It's greater than or equal to. So I'm going to start here, which is at -3. And I'm going to go to this line, which is -2. and then union, because I'm going to connect it to my next answer, and it starts at positive 2, and it goes to, the arrow goes to infinity. And I put a parentheses on infinity because I always have parentheses on infinity because I can never get there. I have brackets on the other numbers because greater than or equal to means it can actually equal these things. So that would be my answer for that one. So we're going to use the number line and the critical point method for lots of these problems.